How's
it going? Is my audio working? Yeah, it's working. Sure. Uh, 1:30, folks. We're going to go ahead and get started. There's a few people, actually quite a few people that haven't shown up yet, so I'll have to stop from time to time to let them in. But let's go ahead and get started. The first thing we're going to do is we're going to take a few minutes here and we're going to go over a machine known as the band saw. Okay. One of the reasons it's called a band saw is because the blades consist of a band of steel that was taken off a big spool, cut to the proper length, in this case 94.5 inches, and welded at the ends to make a little oval guy. Okay. The thing about these blades is that the width of the blade itself determines how tight of a turn you can make on the bandsaw. The big purpose of the bandsaw is to cut shapes and curves. It does not cut straight lines. It's not intended to cut straight lines. You won't be using it to cut straight lines. Not the point. This is one of those machines we do little curves, shapes, things like that. Okay. So the width of the blade determines the radius of the turn that you can make. For example, this is an 1/8 inch wide blade. This is a 1/2 inch wide blade, okay? You can make some fairly tight turns with this little guy, but with this guy, you're not gonna make much of a turn at all, okay? It's not intended to make tight turns, all right? So that's the reason for the band saw name. The way this thing's set up is using a 14-inch diameter wheel at the top and the bottom, hence the name 14-inch bandsaw, okay? The lower wheel is the drive wheel. That's what the motor's connected to. That's what drives the blade. The upper wheel has two functions, okay? First of all, it can be lowered so the blade can be removed and a new one replaced, and then raised back up to tension the blade, to put the proper amount of tension on the blade, okay? It can also be tilted forward and back. This adjusts the camber of the upper wheel and maintains this blade, tracks it in the center of this upper wheel. There's a rubber tire on that wrapped around here and here, okay? So that's kind of the inside guts of the thing. There is a table, there's a throat, similar to what you'd see in the table saw, and then a little throat plate with the blades going down through. Now the blade moves in this direction. In other words, the blade's going down into the table, okay? The teeth, when you mount a blade on here, need to be pointing down. What that does is that, oh, I got people in the waiting room here. Hold on a second, there's like 8 of them. Okay, so let's get them in here. Don't even forget where I left off, because I certainly will. Coal. That was Brent, I think. Brent. Lorraine. Matt. Chris. Anthony. Okay, I think I got them all in. There's still a few that haven't shown up, so we may still be at it. So, where was I? Okay, so the teeth are pointing down, and the blade is running down into the table. So basically what that does is that when you start making a cut, basically holds your board down to the table. You'd never use this machine with your board off the table. In fact, there's not a machine in here that you'd run freehand up above the table like this. If there's a table, it's there for a reason, right? There's not somebody else coming in. Okay, so that's one of the nice things about it. Holds your material down. That gives us the ability to make freehand cuts on this machine that we normally wouldn't do on a lot of other machines, okay? So, other parts of this machine. This is what's called the foot. It's this little assembly right here. Let me close in on this so you guys can see it. Okay. So this little assembly at the bottom right here is called the foot. There's another one just like it, just below the table inside here, okay? The foot exists for a very specific reason. If you look at the blades for bandsaws, they're very, very flexible, right? They bend, they twist, they do all kinds of weird things, okay? So the reason we have a foot is to help control the blade, okay? The last thing you want is this blade twisting and bending side to side and forward and back, everything, while you're making a cut. Makes for a much worse cut. So what we have is a little bit of control here with this foot. Now the foot consists of a couple different things. Number one, it's got little blocks on either side of the blade that were kept in place with these two thumb screws, okay? These two blocks are just barely touching the sides of the blade right behind the teeth. They're not touching the teeth, they're set just behind the teeth. And they're just barely, lightly touching the blade. That helps to control twist, and it helps to control deflection from side to side. Okay. Also, there's a bearing right here, okay? This bearing is supposed to be set about a dollar bill's thickness behind the back of the blade. So when you first turn the machine on, this bearing won't spin. The back of the blade's not touching it. But as soon as the board that you're cutting touches the front of the blade and starts to put back pressure on the blade, the back of the blade touches that bearing and the bearing starts rotating. That supports the back of the blade, all right? Keeps the blade from getting bent too far back, okay? Now, there's a reason for this, okay? When I cut a board, if I have this foot raised all the way up, and I go to cut a board, when I start cutting, here's what's going to happen, okay? This board is going to twist the blade, okay? It can twist well over 90 degrees in either direction, okay? It's also going to deflect left and right, okay? That's really bad. That makes for a very inaccurate cut. So what we do, the rule on the bandsaw is to set the foot of the bandsaw. There's a little lock here in the back that holds this rod. You see it when you get in here. And this one sticks. What I do is I set the tip of my finger underneath the foot, or these blocks, get it down to where now it rests on the board, just like that. And I pins my fingertip between the board and the foot. Lock this down. We generally try to keep this distance about 1/4 of an inch above the material, no more, no less. What this does is this allows these two little blocks, this thrust bearing, to do their job. I can't twist this nearly as far when this foot is close to the board. So it controls drift, which means the blade moving from the left to the right off your cut line, and it helps to control when you're making a turn. It makes it easier to make a turn accurately. Okay? Now, why we use the bandsaw is only for cutting shapes and curves. Okay? This machine is not intended, nor will it cut straight lines under any circumstances. Do not try to cut straight lines. If we need to cut a straight line on a board like this, if we're going to rip this board, we do that on the table saw using the rip fins. We need to cut a straight line this way, in other words, cross cut it. Okay, we do that on the miter saw. That's where we do those things. We don't cut straight lines on this machine. Not intended to do that. It can't do that. All right. What we do cut is curves and shapes. Anytime you come into this machine, you should have whatever curve or shape you want to cut drawn on your board, and you should have an X placed on the side that you're not going to keep. In other words, I would be keeping the larger portion of this piece, and this would be getting tossed away as scrap. The reason for that is we practice in here what's called saving the line. When we run the bandsaw, we save the line, okay? In other words, there is no way you're gonna be able to come in here with the bandsaw and cut absolutely perfectly on this line. It's not going to happen. You cannot do it. That's one problem, okay? There's too much, even with the foot here, there's too much deflection and twisting that gets you off the line. The second thing is this. The teeth on this machine, on these blades, okay? Every other tooth is bent outward, the opposite direction. So one tooth is bent to the left, one tooth is bent to the right, okay? So in other words, it leaves a really rough surface. There's a lot of bandsaw blade marks on the surface when you make the cut. That has to be cleaned up, okay? And that's the function of our spindle sander, our edge sander, and handheld sandpaper, things like that. So we save the line. We never cut on the line. We try to cut close to the line, like this, without letting the blade touch the line and without being all the way out here somewhere. I don't want to have to sand all of this off. It's inefficient. Okay? I just want to have to sand a little bit off. So when I make a cut, okay, what I'm going to do is I'm going to rotate the board. All right. Another thing you'll notice, I never have my hands or my fingers in the path of the blade. Okay, so I start my cut just outside the line. I let the machine do the work. I don't force it. And then once I get to my turn, I'm going to start to rotate the board. And if I get a little far away from the line, if I fade a little bit too far away from the line, I'll back up a hair and I'll alter the angle. I'll angle the board. It's a pretty dramatic angle on the board, okay? I get down here, I start to make my turn. I angle the board. So that when I'm done, what I should have is a little bit of my material left in front of the line, okay? From here I can go and I can sand that off. Let me get somebody in here. Oh, come on. Okay, so a couple safety things about the bandsaw. Okay, I already mentioned one. You never want to have your hands or fingers in the path of the blade, okay? For some reason, you're putting a little bit of pressure on this board to make your cut, and your thumb's right here in the path of the blade, and all of a sudden, right before the blade exits the board, it speeds up, it hits a soft spot in the wood, boom, there goes your finger, okay? It's going to come off faster than you can pull your hand over. The other thing we want to make sure to do is never force our material into this and let the blade do the work. And probably even more importantly, this is one of the things I neglected to mention at the beginning of this was that bandsaws are in large part considered to be one of the safest and easiest to use machines in the shop. I don't consider that to be true. The bandsaw is probably the machine that I've seen the most injuries on. And sometimes it's due to complacency, sometimes it's due to the fact that, oh, look how fun and easy this thing is to use, and everybody wants to use it. But most of the accidents that happen on the bandsaw are this. Okay? So you're cutting away, and as you cut, you get little pieces of material. You'll get a bunch of little pieces around the blade and stuff like that while you're cutting. All of a sudden you realize, man, they're in my way, I can't see what I'm doing. So you leave the machine running and you go to try and flick the piece out of the way. And what happens is, instead of flicking the piece, you flick your finger into the blade. Okay? That's going to take your fingernail and a portion of your finger off a heck of a lot faster than you can pull your hand away. So just like every other machine in this shop, a blade must be completely stopped. The machine must be turned off. The blade must be at a complete stop before you remove scrap material from around the blade. That applies to the table saw, the miter saw, the band saws, the router table, any machine like this where we're going to have scraps that surround the blade. Okay, so fingers and hands never in the path of the blade. Never remove scrap material. I have a hard time saying that word for some reason. Never remove scrap material while the machine is still running. Just turn it off, get it out of the way. Okay? Now, another thing, we want to make sure that if we're cutting, we're cruising along, and all of a sudden we realize either the board gets stuck on the blade or something like that, or we can't turn or we can't do anything, and we realize we need to get the board off the blade. Okay? Oh, I got somebody waiting to get in. So if for some reason we need to get the board off the blade, you need to turn the machine off, let the blade come to a stop before trying to pull it off the blade, or you can pull the blade right off the tires, right off the wheels. Now, if you're just making relief cuts or something like that, and a relief cut is simply something, let's say you're going to make a curve, and that curve is tighter than the particular blade that's mounted in here can handle. In other words, if the blade's too wide to make a turn like that, the blade's not skinny enough, all right, what we do is we make relief cuts, and I'll show you what that looks like. We'll make small cuts that come in, well, shoot, hold on, I'm losing control here. We make small cuts that come in and come close to the mark where we want to be, okay? So that once those relief cuts are made and we come in here to start making our normal cut, as we cut, these pieces fall away and it allows us to make just a little bit sharper turn. We can sometimes make those sharper turns that way, okay? So relief cuts are okay. I can sit here and I can make those relief cuts and pull them off the blade because I'm not very far in the board. I'm not going very far in the board, and it's a straight cut. I'm not making a cut with a lot of turns. It's when you're embedded in the middle of the board, or you're going to have to pull the board off with a bunch of turns in the way, that you're going to pull that blade off. Okay? So that's kind of the basics of the bandsaw. Bandsaws take practice. It's not something you're going to nail the first time you try it. It takes practice. It takes patience. And it's not an incredibly accurate machine. Let me see what's going on here in the way of questions. Okay, okay. Thank you, Hayden. Appreciate it. How big does the piece have to be cut to cut it? Okay, there really is no minimum size. I wouldn't want to take a tiny piece. Your fingers are going to be too close to the blade. But we can cut fairly small pieces on the bandsaw. The little block of wood I had right there that I was working with was 4 inches by 4 inches, which is absolutely less than any of the other minimums on our other machines. For example, the table saw and the joiner have a minimum 12-inch length. The miter saw has a minimum 6-inch length. The planer and the drum sander have minimum 14-inch lengths. There is no minimum on this. I'm very comfortable doing a 4-inch by 4-inch board on here. I wouldn't walk up to this thing with something that an inch or two in on the sides. That'd be a little bit small. What we'd normally do is cut your shapes or curves out of a larger piece and then cut your smaller piece out of it. Or we figure something out, okay? Let me see. Okay, Hayden's running on his battery. Okay, so Hayden, if you lose it, just make sure you take the quiz at some point in time over the course of the day. And explains how to get help for the quiz. If you have trouble with a question or something like that, it explains it in the quiz instructions. Okay, so if you lose it, just make sure you get the quiz done. Okay. Yeah, potato. Yeah, and potato actually has 2 O's and 1 A. Just so you know, just trying to help out there. Potato, potato, potato. Richard, potato. All right. And I understand not having, how about a yam? Do you have a yam, Hayden? Do yams charge batteries? I don't know. I know potatoes can, but yams. Okay, so you charger, it's laggy. So sometimes if it's laggy, if you have too many tabs open, that can help. Oftentimes it's a simple start or shut down and restart of a system to control the lagging. I know my tablet at home does that a lot. If I shut everything down and then start it back up, it clears the cache on it and makes it run a little better. That's all right. It's actually POTA, not PAT, Pay-Toto. It's potato, Richard, not Pay-Toto. So just trying to help out there. Yes, you can retake the test as many times as you like. And just so you guys understand, the last day of class in here is the 28th of January, and the last week of class will pretty much be doing nothing but making sure you guys have everything taken and turned in that you need and that your grade is where it needs to be. So we'll make sure you have time that last week to catch up on anything or retake something if you need to, okay? So no worries there. So that's all right, Hayden. Just if we lose you, you can take that quiz, okay? No worries, okay? There it is. That's what I'm talking, potato. Nope, that's how potato is spelled. Guaranteed it. You got it right that time. P-O-T-A-T-O, potato. Not patoto, patoto. It's Look, here, I'm gonna make it easy for you, okay? No, that's what's on the end of your foot, okay? Here's how it's spelled. Why is this a spelling class? Period. That's potato, okay? Toapate, okay? You're all wrong, okay? You're all terribly wrong. Okay, so let's move on here. So what I've got, I'm gonna zoom this back out. So what we have now is a curve or a shape that has a really rough edge on it, okay? And it is not down to the line that we finally want to see. I don't know if you guys can see that, okay? So let's go over here. I'm gonna move the camera and everything else. We're gonna mosey over here to another part of the shop, okay? If we can do it without me killing myself here. And we'll show you how we clean these up. And then we'll take a quick tour through the quiz before you guys have to take it, okay? So once you've made your cuts on the bandsaw and you're happy with them, you're so happy, you know, it's all unicorns and puppies and butterflies and junk like that, whatever you call it. Okay, what we run across now is a situation where we need to clean it up. And that's what this is for, okay? Whoops, gotta turn it at the camera to get it to work. This is our spindle sander, or more well known as the oscillating spindle sander, okay? Now, this oscillating spindle sander consists of a table, all right? It's got a table, so your material has to be sitting flat on the table. You can't do this freehand up in the air. You can't angle it like this. It has to sit flat on the table. As with all our machines, we want to feed our material against the rotation of the cutter. And don't be confused, sandpaper is a cutter. It actually cuts, okay? It's called sandpaper, but it does make cuts, okay? So we want to move it against the rotation of the sandpaper. So this thing rotates counterclockwise. Now let's have it backwards this way. So I'm on this machine, I'm always going to move my material from the right to the left. Just like on the router table. On the router table, we'll always move from the right to the left, okay? You always want to keep your material moving. Don't set it in one spot. You just dig a big hole right there. Don't use too much pressure, okay? Don't try to take too much off in a single pass. It takes very light passes to clean this up. So you can see how much, I'll zoom this in so you can see how much I have to take off. Get it in there. Come on, focus. Let me go down. Oh, focus. There it is. Okay, so you can kind of see how much I have to take off of this. Right, about 1/8 of an inch from the line. Okay, so that's how much I need to get off of it. All right. So this is actually an oscillating spindle sander, which means it moves up and down. That helps to keep from wearing out a specific portion of the sanding sleeve. And it also helps from overheating, and it's a cleaner finish on it. We can actually change these spindles to different diameters. There's different diameter spindles and things like that. And you can tell this thing's kind of worn at both ends. That's because as it wears at one end, we'll pop it off and we'll flip it over to start using the other end. But when I start doing this, I'm going to use real light pressure, and it doesn't take much to get it down to my line. Really easy. This is one of those machines that's kind of nice because we can't have a couple people working on this machine. We can have somebody working over here and somebody working over here. It's not where you're going to have to sit and wait for one person to get done. It's an easy machine to use, and you shouldn't be at this machine long. You should never be at a sander very long. If you're having to sand for a long period of time to accomplish your task, you've done something wrong before coming here, okay? You haven't done it right. So, in other words, if I've got this much material to take off on this thing, if I'm way down here, I need to go back to the bandsaw and get it closer to the line before I come over here. So we just take it, we sand it. This will not only get all the bandsaw marks off, but it'll allow us to carefully and with a little more accuracy get down to our line and get it to the finished shape that we want, okay? So that's pretty much how we get down to it, okay? You can see there's just the tiniest bit of my line left all the way along here. I've gotten rid of all the bandsaw marks. There's a lot of crud on there from that felt pin. Gotten rid of all my bandsaw marks. I've got a nice edge, and that's what we do, okay? We do not sand flat, straight edges on here. If you go to the miter saw and you cut a board to 12 inches long, and when you take it back to the table and you realize that, oh man, it's an 1/8 inch too long, I cut it to 12 1/8, I'm just gonna go over to the edge sander and sand that 1/8 of an inch off. That's not how you do it, okay? You go back to the miter saw and trim that extra 1/8 inch off, okay? So let me turn this so I can see. Yeah, it's raining pretty bad outside. So, yes, well, not really. Okay. All right, so let's talk about the quiz, okay? So there are 5 questions on the quiz. They all apply to the miter saw, and here are the questions, okay? The first question is true or false. The table saw is the best choice when cutting to length. That is false, okay? So I've got a board here I made some marks on. It's really high-end and professional looking, okay? Let me move this down a little bit. Just take the top of my head off there, okay? This is the type of cut we make on the miter saw, okay? This is a cross cut with the blade going across this way, okay? We're altering the overall length of a board. When you see the word cross cut on the safety test or on this miter saw quiz, or at any time you see the word cross cut, you should be thinking miter saw, okay? That's what it does. You see the word rip or rip cut, you should be thinking table saw, okay? That is ripping to width. That's with the blade going in this direction, okay? That is a rip cut, all right? Table saw, rip fence. That is a cross cut, okay? Miter saw, cross cut, cutting to final length, okay? So the question was, true or false, the table saw is the best choice when cutting to length. That is false. The next one, a board must be at least blank inches long in order to safely cut to length on the miter saw. The answer is 6 inches long. That's the minimum length on the miter saw. A dollar bill is about 6 inches long. I don't know about 20s and 100s. I don't see those. I see dollars, ones. That's all I ever see. So 6 inches long is the minimum length on the miter saw, okay? Minimum. Next question. Oh, I'll just read it again. A board must be at least 6 inches long to safely cut to length on the miter saw. Next question. Always use a stop block when cross-cutting more than one board to the same length on the blank. Here's what you should see in this question. As soon as you saw that word cross-cutting, okay, you should be thinking miter saw, okay? So always use a stop block when cross-cutting more than one board to the same length on the miter saw. In other words, let's say we've got a board here, okay? And we've got this board, let's say it's like 30 inches long or something. We need a bunch of 5 or 6 inch long boards. What we cannot do is measure from this end, make a mark at 5 inches, draw our line, make a cut. Measure from this end, mark at 5 inches, draw a line, make a cut. We can't do that down the length of the board. We're going to end up with a bunch of boards that are a little bit different in length. Okay. For example, let's say I've got a 4-foot long board and I need 3 pieces out of it that are exactly 12 inches long. If I go over there and measure and mark each cut individually, I'm going to end up with one board that's a 1/16 of an inch too long, one board that's a 1/16 of an inch too short, one board that's an 1/8 of an inch too short. I'm going to end up with 3 different length boards. That is bad. I would rather have 3 boards that were all a 1/16 of an inch too long, in other words, all exactly the same length, than have 3 different length boards. That's what a stop block provides for us. It provides consistency in our cuts. We get consistently the same length boards. Imagine the steps or the ladder or the rungs on a ladder. Okay, they've all got to be exactly the same length, or the sides of the ladder are just going to be like this all the way up. Okay, so it gives us consistency. We can cut the same length every time. So always use a stop block when cross-cutting more than one board to the same length on the miter saw. Okay, next question. The edge of your board must be tight against the blank on either side of the blade when cross-cutting on the miter saw. The edge of your board must be tight against the fence. Okay, we have a fence there for a reason. If for some reason you don't have tight contact on either side of the blade, tight contact with the fence on either side of the blade, I'm talking like right here and right here with the fence, you're setting yourself up for the possibility of a kickback. Okay, and what that means is the blade is going to get pinched by the board and it's going to throw this up in your face. You don't want that. Now, that being said, if you have properly followed the order of operations in our shop, okay, in other words, you have done thickness first, the faces. You've done, let me get this so you can kind of see. So if you followed the order of operations properly in our shop, you've done thickness first, or you've milled the faces, both faces. Then you've done width, you've milled the edges, both edges. Okay, if you've done those 2 steps in the right order before going to the last step, length or ends, there is no way you're not going to be in tight contact with the fence on either side of the blade. Because what you've done in those first 2 steps, the thicknessing step, treating the faces, and the ripping to width step, treating the edges, what you've effectively done is created 2 nice, flat, parallel faces. Both faces are perfectly flat and parallel to each other. You've created 2 nice, straight, flat, square, parallel edges. So this edge and this edge are parallel to each other. They're nice, flat, and straight. There's no way that board's not going to sit perfectly flat against that fence and against that table. So if you get kickback on the miter saw, you've screwed up on one of the other steps in prepping your board before getting to the miter saw. Okay, the miter saw is the last step in the 3 steps for prepping a board for use. Okay, so the edge of your board must be tight against the fence on either side of the blade when performing cross-cutting operations on the miter saw. The last question, how many cuts does it take to accurately cut a board to length on the miter saw? It takes 2. The first cut is a trimming and squaring cut. Okay, you have to square at one end before you can measure from that end out here and make your mark and cut the opposite end. Throughout the process of our order of operations, you have to mill or treat or do something to every single surface on this board, both faces, both edges, and both ends. If you don't make 2 cuts, trim this end, measure and cut to length this end, you'll leave one end untouched, and you cannot do that. Okay, so it takes 2 cuts to accurately cut a board to length on the miter saw. All right, so let's talk about how you take this quiz and where your resources are for any trouble you might have. I'm going to share the screen. What are the steps? What were the steps going or stages again? Okay, Richard, if you can remember the word fee, F-E-E. I'm going to type it here so you can see it because my mouth doesn't work great all the time. If you can remember that word, that stands for faces, then edges, then ends. And that's the same as saying thickness, then width, whoops, then length. Okay, that's the same thing. Faces, edges, ends is the same as thickness, width, and length. Okay. Yes, it does. It makes a huge difference what machine you use first. We don't have the time to cover that today, but we will cover that again. We've covered it once. We're going to go over it again. Okay. So don't sweat it right now. We're going to go over it again before we get out of here at the end of the quarter. Okay. So let's talk about what you need to do for this quiz. I'm going to share my screen. And when you go to the home page here, all you have to do is go to modules, clickety-click. Here's Wednesday right here. Here's our quiz. When you open this, there's going to be a little explanation as to what you need to do. And here's what it says. Today's quiz covers the safe operation of the miter saw. Below, you will find a link to a copy of the Woodshop safety test answer sheet. That's this blue link down here, okay? This link will take you to a copy of the safety test with all of the correct answers included. If you find yourself having difficulty with any of the answers on the quiz, simply click on the link and find the question on the safety test that you're having trouble with. The correct answer will be found there. All of the questions on the quiz are taken directly from the safety test. Nothing has been changed. So let's take a quick look at this. Okay, here's a good example. The very first question on the quiz is the same as the very first question on this test. True or false? No, I'm sorry. I take that back. That was stupid. It's number 6. True or false? When cross-cutting on the table saw, you should use the rip fence. It is false. The second question on the quiz is this one right here. A board must be at least 6 inches long to safely cut to length on the miter saw. The third question is right here. Always use a stop block when cross-cutting more than one board to the same length on the miter saw. And that A refers to right here. Okay, you'll have multiple choices in the quiz. Okay, the next question. The edge of your board must be tight against the fence. The edge of your board must be tight against the fence on either side of the blade when performing cross-cutting operations on the miter saw. And the last question, how many cuts does it take to accurately cut a board to length on the miter saw? It takes 2. Okay, so all the questions that are on the quiz are found here on the safety test. You just have to look them up, okay, and the correct answers are here, okay? So go ahead and take the quiz. Once you've taken the quiz, you're welcome to take off. You're done for the day, all right? Thanks for being here. You guys have a good evening, and I will see you all tomorrow. I will stay here till the end of class, so if you have any questions, all right? Bye, folks.